Hi everyone, my name is City and I'm a rising 8th grader from Wayne, Pennsylvania. Last year I was a part of NASA Girls program where NASA provides a mentor to work with me. My sister and I had the chance to do different activities with NASA Engineer, and I was really inspired by it. I am so excited to moderate this panel today, so let me tell you who we have with us to celebrate the legacy of Dr. Sally Ride, the first American woman in space. When I say your name, please take a moment to introduce yourself. Dr. Karen Flammer, co-founder of Sally Ride Science and space physicist.
Hi, my name is Karen Flammer. I'm honored to be here today.
Ms. Lori Garver, the Deputy Administrator of NASA.
Hi everybody, I'm Lori Garver, Deputy Administrator of NASA, and I am here because of Sally in so many ways, so it's an honor to participate.
Dr. Katie Coleman, NASA astronaut and chemist.
Well, meeting Sally inspired me to be an astronaut, so there's no place I'd rather be today.
Dr. Amber Strawn, NASA astrophysicist and James Webb Space Telescope scientist.
Hi, I'm so glad to be with all of you today. I'm really honored to be on this panel and excited to talk about some of the influence that Sally's had in my life and in all of our lives.
And Dr. Mamta Patel Nagaraj, International Space Station Engineer and Scientist and woman at NASA Project Manager.
Hi, I too, just like the rest of the panel, I'm excited to be here. I grew up admiring Dr. Sally Ride, and I can't wait to have this discussion with everybody.
Thank you, ladies, for being here with us today, and I'm so excited to have a conversation with you about science, technology, engineering, and math, or STEM. Before we begin, let me remind our online audience that you can send questions using the Twitter hashtags CelebrateSally and AskNASA. Okay, so let me start with a question for anyone on the panel. Did Dr. Ride influence any of you when you were younger?
I don't know. I'll start. Both Katie and I even have talked about this together. I was in college when Sally flew. She was, of course, Dr. Ride to me then, and frankly, I don't think I really paid attention to the space shuttle program until STS-7. So she had a great influence on me, and then throughout my career, because I got to know her, served with her in really advancing the space program that we are participating in today. She shaped my life in this program. She was someone who saw both the importance and value of space for looking out as well as looking back at our fragile planet, and she moved, I think, the program in a direction that is providing the very best value to the American taxpayer and really to the world.
Okay. Dr. Flammer, as one of the founders of Sally Ride Science, would you mind telling us about your inspiration of starting the organization?
Definitely. So, you know, Sally's done so many things in her life, and I first met her. We were both female physicists at UCSD, and she had just started the educational outreach program, which I still run today, called now named Sally Ride EarthCam. And working with her on EarthCam changed my career path. I was doing theoretical research in space physics, and all of a sudden Sally just started EarthCam, and we started reaching out to middle school students and seeing how we could engage them in STEM through this incredible opportunity of taking pictures of our Earth from the EarthCam digital camera now on the space station. And it really gave Sally the motivation and the idea for us to start our own science education company, Sally Ride Science, and use our background as scientists and our experience and our paths to getting to our careers to try to really figure out a way to just broaden that experience and reach all students, and particularly girls, and provide resources, curriculum, tools, and products to let students know, and particularly girls, that STEM careers are available to all students. And I'm just so proud that Sally, with Sally's efforts, that Sally Ride Science has turned into a very strong organization that continues to reach teachers and parents and students, and hopefully we're going to have a huge impact on improving STEM education and widening the pipeline into STEM careers.
So how many schools have you been at so far?
So the numbers, through all of our teacher training, actually now we've trained probably tens of thousands of teachers on ways we think we can help teachers engage and ignite students' interests in both STEM and STEM careers, and that really translates into we've touched over 1 million students. And the other programs that we continue to run, like NASA-funded ISS EarthCam, has also reached over 500,000 students, and we continue to outreach and grow that program. So, I mean, collectively, when you think of all of the programs that Sally initiated and Sally Ride Science continues to support, we're reaching millions of students. And some of these students are not only in our country, but worldwide, particularly through ISS Sally Ride EarthCam.
Are girls liking this program, or is it just boys? Or
oh yeah, no. I mean, it's whatever tools and resources that we provide are equally useful to girls and boys. It's just that we're paying attention we're paying attention that we need to get more girls and underrepresented minorities involved and interested in STEM and made aware of just the wide variety of STEM careers, because we really need to broaden the pipeline of our young students into these careers.
Mm-hmm. Dr. Strawn, I really love the pictures from the Hubble telescope. Can you tell us more about the James Webb Telescope that will replace it?
Sure. Well, first of all, we like to say that instead of being a replacement for Hubble, the Webb is going to be the successor to Hubble. So we're really building the James Webb Space Telescope to answer the big science questions that Hubble just can't quite answer. Of course, Hubble's been amazing. It's been in space over 20 years now, so it's doing a great job, and we all love Hubble. My own research, I study star formation in distant galaxies, and most of my research that I do is done with data from Hubble, because it's so amazing. But the Webb telescope is going to be about 100 times more powerful and 100 times more awesome, at least. So we're really excited about the really great things we're going to discover with Webb. We're going to discover things like the very first galaxies that were born in the universe. We're going to learn about how galaxies and black holes form and change over time. We'll learn about how stars are born, and we'll also learn a lot about exoplanets, planets orbiting other stars outside of our solar system. So we're really, really excited about the awesome science we're going to get to do with Webb. And the engineering that goes behind it is amazing. This telescope will be by far the biggest telescope NASA's ever put into space. It's one of NASA's top 3 overall priorities. So it's a big deal, and it's a big telescope, and it's really such an honor to be able to work on such a fun mission. And from the perspective of the influence of Sally Ride, you know, I believe I was a pretty young kid when she went on her first space flight. So for me, I feel like she and others like her have really set the stage, and those pioneers have allowed women like myself to really be able to become an astronomer and astrophysicist that I am, and to be able to take advantage of some of those great opportunities that NASA has for women.
Oh. When do you think the telescope will go in space?
So we are scheduled to launch in 2018, so just about 5 years away. We're really busy right now putting the pieces of the telescope together and testing the telescope. So actually a lot of the telescope has already been built, and so now we're under the major task of putting all of those pieces of the puzzle together and making sure everything works before we launch. So we have about 5 more years, a little over 5 years to launch, and we're really excited about what we're going to learn from this awesome new telescope.
And how long have you been working on it?
So I've been at, I work at NASA Goddard in Maryland, and I've been there about 5 years. It'll be 5 years this fall. I started out as a postdoc and then became a full-time NASA employee just a couple of years ago. And when I was doing research as a postdoc, kind of full-time, again, I was working mostly with data from Hubble. But all the time when we're working with this with Hubble data, we're looking forward to what Webb is going to be able to do, and we started long ago asking those big questions of the big questions in astronomy that we can't answer now that Webb will be able to answer. So I've only really technically been working on Webb for a few years, but I've been thinking about it for a long time.
That's very cool. Dr. Coleman, can you give a few examples of the science that astronauts do on the space station?
There's a lot of amazing things. I guess, some of the ones that are easier to see are experiments that have to do with like liquids. What do liquids really, really want to do? We have a lot of experiments about that because down here on the ground, with gravity, basically it overwhelms some of the smaller forces that tell liquids what they're going to do. And so what we do up on the space station is actually some experiments that are simple and some that are pretty complicated. If we just, for a simple thing, if you just, squeeze your orange juice bag too tight and it comes out of your straw, you're going to have a sphere of water or a sphere of orange juice. And that's because surface tension is the dominant force there. Well, we use that to understand things like everything that is manufactured down here in a factory that involves flow through a pipe. That means, making things out of plastic. That means making food. That means manufacturing things. That means processing fuel, everything. All those things, we need to understand what do liquids really want to do. And so we go to a microgravity environment to investigate those little forces that come into play, especially at the walls. And that includes the walls of like us, in our veins and the way liquids interact in our bodies. There's also combustion. Understanding how things burn is a pretty involved, complicated process. And it happens really fast down here on Earth because there's a lot going on. We have gravity keeping the heavier things down, the lighter gases which are being produced rising, new fuel is swooping in, and so there's a lot going on. It's hard to literally take pictures of or take data of. So up in space, where those lighter things are not going to rise, our candle flames are more spherical, our equations are easier to solve, and we are able to understand things about how things burn, how to burn things more cleanly, how to burn things more effectively, how pollution is formed, not formed. So that's just some of the physical things. And then if I start into what happens to us up there, it's not just about how to live in space, but it's about how to live down here. Because I don't have gravity up there, or not much, I lose bone and muscle about 10 times faster than a woman who's 70 years old that has osteoporosis. So I would come home after a 6-month or a year mission like a piece of spaghetti if I didn't do some things to keep strong bones and strong muscles. And it turns out that the lessons that we learn, because they happen so fast up there, that process happens so fast up there, it makes it easier to study. So literally by taking blood samples and urine samples and saying, okay, Katie, eat these things. Okay, now this week, eat these things. We can see the effect of diet on our bone health, whether bone is growing or dissolving. We can look at the effects of different kinds of exercise. And all those lessons that we're learning, they certainly helped me. I can only talk about my own experimental data, but I actually came back to Earth with all the bone and muscle that I left with. It's not probably the same. And that muscle and bone are probably rebuilt, and we're still doing experiments to understand how that might be different. But I came back with a lot more bone and muscle than astronauts used to do. And in fact, my crewmates, it's happening to them too. And that means that we're understanding how to keep people strong when they're older as well. So lots of lessons about the body, lots of lessons about physics. And it's an amazing laboratory. The lessons will never stop.
Were you nervous when you first went to space? Like, how did you feel?
I tell people, not exactly nervous, because you've been trained to do a job and you're thinking about that job. And actually, as a human being, in terms of launching, just so excited. And even though you know it's going to happen, you climb into that rocket just like you have in practice, and you do all the things in practice, and you know what time those engines are going to light, when it really happens, it's so clear that it's a pretty amazing thing when people leave the planet. It takes a whole team of people on the ground to get that all to happen, and it's an amazing thing. I was just really excited. I'll tell you what I do worry about up when I'm up in space, or just when I'm doing my job in general, is I worry about making a mistake. I mean, we're all human, and yet I feel like I have this important job where I'm responsible for doing my best. And I was in fact, responsible for catching the HTV supply ship with the robotic arm, the second time we'd ever done that. I was responsible for launching the Chandra X-ray Observatory. You know, it's like the Webb Telescope where, you know, hearing it described earlier, it actually brings back to me what we all felt about being part of something so big and important, and you don't want to be the person that messes it up. And the only way that I deal with that kind of, let's call it fear, is I just have to know that I did all the preparation that I could, that I did all my practicing, and that I was ready as I could do, as I could be, and ready to do my best. And that's how I get that kind of fear behind me, and I get on with my job.
Mhm. For Ms. Garber, you're the Deputy Administrator for NASA. Do you have a STEM background, and can girls in other fields pursue careers at NASA?
I do not, in fact, have a STEM background. My undergraduate degree is in political science and economics, a master's in science, technology, and public policy. So I am a living example that if you are a non-STEM person, there are many careers for you at NASA. In addition to those that I was involved in, many educators work at NASA. We have government affairs specialists, communications people, the folks who are really helping us with this Google Hangout now, professionals in their fields who I would say what we all share is, of course, love of challenge and doing things that have not been done before and doing them in a way that provides real benefit back here on Earth. As a public agency, we spend the taxpayers' dollars. So I have really been able to utilize my background in economics and political science and public policy in a way that hopefully can best manage an agency that is stewards of nearly $18 billion of public dollars, working with Congress, working with the President and the rest of his leadership team in the White House so that they understand the value of what we're doing at NASA. One of the reasons, though, that I can do my job is because we have these unbelievable professionals in the STEM fields who are able to explain the technical details to us in a way that we will be able to convey that information to folks who need to know to make decisions about how we spend the country's resources. And it is a privilege to work with them. So I really encourage people to go into STEM fields because the preponderance of people who work here have STEM backgrounds. But if your passion is space law, you can have a place at NASA as well.
For everyone on the panel, how may have you watched Sally Ride's first flight, and do you remember your thoughts at that time?
Well, I'll start. I already mentioned where I was. I remember where I was. There were several of us who might have skipped class in college to see her launch. And in particular, I remember her landing because, of course, with the space shuttle landings were a very special thing. And being able to see her walk off the space shuttle was is something I remember to this day. Now, of course, being able to work with her later became probably cemented those memories. But knowing where I was at that age while she was in space was something that stuck with me.
I'd like to add that I had just started a PhD program in physics at the University of California, San Diego during Sally's first flight, and Sally ended up there years later. But I just remember thinking that I just needed to meet that woman someday. And it's just still. I'm so grateful that she ended up coming to UCSD, and I did end up working with her and forming a company with her. And as I mentioned earlier, it really did change my focus, and now you know, my passion for STEM education. But it really, again, seeing somebody, in my mind too, not only be a hero and be the first American woman to go into space, but it was also the way that she did it and the way that she handled herself. And you could just tell, even from afar, not knowing her personally, that she was going to make a difference in pretty much everything that she set out to do.
For Dr. Katie Coleman, how many female astronauts are there?
The exact number, I think there, you know, I'm not a good sort of exact number person. I want to say, and maybe Dr. Garver can help me out, 53 that there's ever been something.
I think that's pretty close, but I'm going to tell you that we're 4 more than we had a month ago with our most recent announcement. And I know specifically they are not astronauts yet. In fact, we still call them ASCANs, as in astronaut candidates. But it was very exciting to be able to, for the first time, have a new astronaut class that is fully representative of females in the population. So out of 8 astronauts candidates for being women, but I think that's right. It's the low 50s.
And you know, and the other part of my answer is I would say not enough.
Exactly.
You know, just in the, you know, basically in my job, I mean, we have these teams of people, and I would say the majority of them are often men, and that's probably true for all of us here on the panel. And it's why we're here with UCD, and you know, it's because basically, you know, until I met Sally, I had this impression of what being an astronaut was like. And I still see this picture around the Johnson Space Center, and it's the 7 original astronauts standing in front of a fighter plane. And nothing in that picture makes me think it could be me. And I met Sally Ride when I was in college. I went to a lecture. I shook her hand. She doesn't remember. You know, we've both talked about this. And so it wasn't actually the conversation that we had. It was the fact that I could see her across an auditorium and realize that this was something that I could aspire to. And it's still very necessary. And in all these careers that we talk about in STEM, still a lot more guys than women. And sometimes the skills that women stereotypically bring, I think, are, I'll say, underappreciated or maybe underutilized, in that stereotypically we do actually bring some great team facilitation skills. I'll never forget Eileen Collins said we used to do national outdoor leadership training, you know, go out in the woods and learn things with our crews, which is very valuable. She said, what is this outdoor leadership? What about indoor leadership? I show that every single day. You know, so there's a lot of skills that women bring, and I think it's good to be a face out there so that the girls like yourself and girls like yourself standing up is really important too. Realize that there's a lot of things to do in the world, and we need to be doing them, and we need all of our girls doing them as well.
You know, Katie, you're reminding me, so with the earlier question that Sydney asked us, I'm too young to have actually watched Dr. Wright have launched, but my sister, who's older than I am, I always credit her with spurring that interest in science and math in me. And she was just at that age where she can remember Sally going up into space. And she never met her, and there was no direct contact with Dr. Wright. But I think it was just that image that all of a sudden the opportunity to go into space was available to women. I think that's really what made the difference. The progress that NASA and the country had made in sending her up, I think, was just, it was the presence of a woman going up into space that I think made all the difference in the world. So for me, while I didn't watch her launch, even when I watch it on tape or I watched it when I was little, to me, I felt like I was watching her launch. Like I actually felt like I had been old enough at that time. And it's remained my inspiration to keep working in science and math and whatever it is that I'm doing to support our space program. So every time while you were talking, that's what I was thinking, that absolutely. I never had a conversation with her, but it was just her presence that mattered.
And sometimes I'm a little overwhelmed by how much work we have to do, but then there's days like yesterday, my trainer at the gym, or we have several trainers, and she told me that her daughter, who's 6 years old, wants to have a jet fighter pilot birthday party. And I said, you know, we are getting there, aren't we?
Why do you feel that there are more boys getting STEM than girls?
I have a couple views on that I would share. I do feel we have not done enough to explain STEM careers in a way that shows how they really do advance society and help humanity. I think women, as Katie mentioned, some of our particular areas of interest are more along the lines of being able to advance society in a positive way. And right now, women are going into the medical fields at equal or greater shares. That's the part of STEM, the biological sciences, that they're going into. And engineering, some is the least. And so I think we need to connect more what we're doing, and in particular in the space programs, to benefit the public, is something that I think will connect more with women, as well as the role model issue that Katie laid out. I mean, here now Katie is one. I feel like that when I was here in the 90s, I ran the policy office, and I was really proposing a serious concept to have an all-female shuttle crew. And people laughed about it. And I said, well, we have had all-male shuttle crews for decades. And people don't laugh at that. You know, we could still be pursuing, I think, things that are really outstanding. And again, that's why I'm so proud of the astronaut selection this last couple of weeks, because role models do in fact matter. We've all, in a way, been touched by Sally, and that's why we're here. But we also, I think, need to describe our careers in a way that really shows women what they can contribute through STEM careers.
I agree so much, and I want to add that to reinforce what you said, that I mean, the differences between that males and females bring to the table in most cases, you know, is different and complementary. And a lot of the latest data and surveys shows that females care greatly about improving the environment around them, and they care about helping people. And what we need to do is make that translation to show them how the misconception that science is not a humanistic effort, and STEM careers are either too esoteric. And again, as you pointed out, it's over now 53% in this 2013 freshman medical school of females, because again, that's a caring profession, but there are so many engineering and computer science careers, again, where the largest discrepancy in males and females is now, that have such relevance, in fact, increasing relevance to our everyday life. And we as role models, Sally Ride Science, in our job as training teachers, we really have to let parents and teachers know that the careers out there now in STEM are affecting all of our everyday lives and helping people here.
How can we help parents encourage girls to pursue STEM from a young age?
So I think most importantly is provide them with examples and role models. And it's got to be, we focus, Sally Ride Science, we focus on upper elementary and middle school students, because you can't wait, you know, and students usually are in the pipeline to
Okay, for everyone, do you feel it's easier for girls to pursue careers in STEM now than it was when Sally flew?
Well, I'll say easier, but I don't think it's easy enough yet. I think there's still a lot of things that, you know, that tell young girls that basically that might not be for them. I mean, I myself, when I am given a talk to a school, when I look around for questions at the end, and I'm probably a little bit nervous, and I mean, you know, I talk all the time, and at the same time, there's just a certain kind of anxiousness and trying to do everything right and wonder what time it is and if you're supposed to be done, all those things. So I'm a little anxious. And when I ask for questions, it's the easiest thing in the world for me to pick the first hand that comes up. And if I do that, it is gonna be a boy. I mean, and as a speaker, it's easier for me to say, what's your question? Because there we went on to the next thing, and I'm feeling more comfortable. And so I have to force myself to just take a little time, wait a little bit, watch for those girls' hands, and maybe I'll answer, one question over here, but I kind of look at somebody I can kind of tell has a question, and I look at them in an encouraging way. And so I think for all of us, all parents, to try to just really keep your level of observation up and monitoring your own behavior, the times that you stereotypically give your daughter certain toys and your son certain toys. I mean, I have a son, so I have to kind of think about what I encourage him to do.
So
Sorry, go ahead, Lori.
Katie and I both only have sons, and we've talked about that. But I would like to think that it is better, but we still have a ways to go. I know in 1970s when I was in high school, my mom really was upset when I got back to senior year in high school, and the boys who'd finished the math had been arranged to go off to the local college to take calculus, but no one had bothered to invite me to do the same, even though I had also completed all my math. You would hope that wouldn't happen today. I'm not 100% convinced it wouldn't, and I agree. I think that there is a different standard, even for me at the Deputies Council with all the other agencies here in the government, a couple of women, and we are putting our hand up first and really trying to make a difference. And I think the more people do that, the easier it will be for parents to encourage their girls.
And I'd like to put in that I think there's two things that have made it easier and will continue to make it easier. One is having women like Lori, to be honest, and she won't say it about herself, so I'm going to say it about her. That every time I talk to somebody who's high up at NASA, and I say, I can't believe how encouraging you are. So for instance, I just recently became pregnant, and so now I'm asking all these questions about what I'm going to do, and every time I ask these questions, I'm nervous going in, and I'm so comfortable coming out. And I will tell you that more than once, people have said, well, it wasn't always like this, but we have the management at the top that's making it easier for women to stay in these careers. So I think there's a couple challenges. It's getting girls interested when they're your age, Sydney, and then it's keeping them in there when they're my age. And it comes time to decide about having children and childcare, and life just gets really complicated later as we get older and we have to start making these decisions. So I think there's two things. So it's having women like Lori up in those higher positions that are very supportive and telling the right people, we need to provide X, Y, and Z. The other thing I think matters is parents like yours. So Sydney's dad, and the reason I know Sydney so well is she was my mentee in the NASA Girls program she mentioned. And I have to say that your dad is just so supportive of putting, and he has 3 daughters, of putting all 3 of them and exposing them into these programs, and programs that touch on all sorts of STEM topics. His oldest daughter just got into a program for computer science, and I think it's fabulous. And he did not have any hesitation in saying, Mom, do you get to meet my daughter? Would you write her a recommendation letter? And so I did, and she got into Penn State. And I just think it's taking that extra step. So I think parents like yours who find those opportunities and put their daughters in those opportunities, and something like what Katie said, being conscious of the choices we make for our daughters versus our sons and making it an equal choice.
Yeah, and my dad also, he put me and my sister in this program where you build Lego robotics, and I really like engineering, so I really thank him for pushing me into programs and like those. Yeah.
That's really great. I was also going to say along those same lines is that I think it's so important for parents just to encourage that natural curiosity that kids have. So I think, most younger kids that I meet are just naturally curious about the world, and that's exactly what STEM is. And so I know for my personal case, I grew up in the middle of nowhere in Arkansas. Neither one of my parents even went to college. And so when I started, talking about going to NASA or becoming a scientist, it was a little, it was a little strange. It was a little different. It wasn't part of my, my family's past experience. But my parents were always so very encouraging of my interests. And so I think just that, I mean, it seems almost like a small thing, but just that kind of constant reiteration that your kids can do whatever they want to do, and that, just encourage that natural curiosity that kids have can go such a long way, and it really did for me personally.
Along those lines, I think that often we think that if we would encourage girls, if they see STEM, if we get them in the right place with STEM or the right introduction, that that you can help with fixing things, all those things, that it'll happen. But I think we also need to address the fact that these fields aren't easy for everybody in the same way. It's not always going to be an easy thing. I mean, for example, I will confess openly, I do it all the time, that here I am, a scientist, I'm a polymer chemist, and physics is hard for me. I don't actually particularly like it, okay? But is it essential in what I do professionally? It certainly is. And I mean, not only that it's part of it, but also that I really need to evaluate things using a reasonable working knowledge of physics. And so does that mean that physics isn't for me just because it's hard for me? No, it means that I have to take more time. I have to realize that just because I have more questions, or I need 5 explanations, or I have to do all of the homework problems, not just the first few that convince me, yeah, I can do this. And so I think addressing that especially in girls, where it doesn't automatically take off for them, and just because it's not automatic or intuitive for them, doesn't mean that they don't need it, because it's a part of lots of different kinds of solutions, and I think that we're all going to have to be learning new things all the time.
That's such a good point, because I hear from a lot of teachers that a lot of the girls in their classes say that they don't want to take the higher math classes or even the physics class because they know that they're hard, and they feel that they're harder for them than the boys in the class. And I think we as parents and educators, really, the whole thing about effort equals performance. And Sally, when she gave talks, used to tell students how hard she had to work, that it didn't come easy to her. And it's a misconception, again, that only the brightest of the bright can actually choose to go into science or math. It's just like sports. There's all people of all abilities, or playing music, you have to practice and train, and that's where you get results. It's the same thing with math and science and anything worthwhile.
Mm-hmm. This next question is from Twitter user Adarine L. What are your thoughts on adult women with math degrees looking for a career change in NASA? This is to anyone.
Well, for careers at NASA, I would definitely, as I said, I encourage non-STEM, but primarily we are hiring people in the STEM fields. Just looking at our data, even though we have a flat budget at best these days, we have about 1,000 new hires a year. And right now, again, I just happened to look at the data, we have 37% of those have been women. We need to increase that, and a largest percentage of those are in STEM fields. So I'd really encourage people to look at NASA as a career at any age or level. We definitely have throughout our centers where we have space science, earth science, human spaceflight, aeronautics across the country. And so I would definitely recommend at all levels, and certainly with a math degree, to apply to work at NASA.
And just tagging on to what Lori said, anyone who's interested in a career at NASA, and particularly around your age, high school, college, can look at women.nasa.gov, and there is a link that is for careers and internships, and that would help provide a resource for it.
Dr. Coleman, like Sally, are there any challenges that you overcome in your careers?
Well, I would say, like everyone on the panel, yes, there are, just because we all have really, we have big goals, and I think all of us probably have things that come easily to us and things that do not, and things that maybe do not just because of the environment. I think working in an environment where it's mostly guys, where Sometimes the things that they value, the things that they promote people for, the things that they think highly of are not always the things that, maybe you bring to the table. And at the same time, eventually they kind of go, wow, Katie really made that work. So, I think it all kind of works out. Sometimes the physical challenges, what I encourage people to think about, like for example, in the spacesuit, I'm the smallest person that is qualified and on the spacesuit team, so to speak. I had a suit up there on the space station. Unfortunately, did not get to go out and use it, much to my dismay. We always hoped for something like really expensive but not dangerous to break, Anyways, but that didn't happen. But I was really proud to be on that team, mostly because it's a pretty physically large suit. It involves some strength, but at a certain point, it actually just involves your head and understanding what your body is doing. And if you're a big, strong person, okay, who really fills up that suit, there's some things that are going to come more easily to you. And as a smaller person that has some of those challenges, basically I would make sure I did all my head work before I got into the swimming pool to be practicing or in the position where we'd be doing it on the space station. I've gone through every step of that procedure so that I don't really have to think about anything. I can focus on the part of it that might be more difficult to me, which is, physically grabbing it or grabbing it with both hands and being able to reach and those kinds of physical things. So when things are challenging, I encourage people to just open your eyes and really look and see, what are the things that you bring to this difficult situation, even if it is just how to get the help that you need in order to get the goal done for the team.
So I just have to add on with that suit discussion, Katie. You and I don't think have had this, but if hopefully I would like to think if someone like me were in my job 20 years ago, you wouldn't have had to overcome that challenge as much. We had a sad tale with the suits in the sense that I think we're talking about challenges we have to overcome and maybe hopefully some unintended consequences. When NASA had to limit the types of suits we had, the sizes of suits, we were just going to do medium. And then, of course, we were going to do medium and large. And then we threw in the extra large, but we never made the small suits. And let's see, who was making the decisions at those times were the larger males. And what we left off were a population of primarily females who then now are limited when they can't go to space because you have to be trained in the suit to go to space and you have to fit the suit. And I learned about Katie as the smallest person who would fit the suit, and that must have been a huge challenge. And I would like to think that we would not make that decision today. And I have to tell one little story. Edward Teller actually said once he was asked whether or not women should go to space. He thought about it, and he answered that yes, only women should go to space. More brains per pound. And I would just say that both for Dr. Coleman and for Dr. Rye, that would really be the truth. That is some mighty brains packed into a little frame.
Well, and it's nice to see in actually the new suit development that we're doing for going on to the moon, asteroids, Mars, and we were doing a lot of looking at what does a spacesuit really mean? Like right now, one of the concepts that we have is a sort of a big balloon that really protects you. And yet there's other ways to do that where you have maybe something closer to the skin, something that might fit people differently. I mean, we're really looking at a lot of different concepts and being more inclusive. And in fact, there's some pretty neat spacesuit design done at MIT by Dr. Deva Newman that's been in the news a bit, the biosuit. I mean, I'm not saying it in any way that is a way that NASA's going. We are looking at a lot of different things, but as you said, if someone like you was in the position of making those decisions long ago, they might be different. And I feel like we do have women in the workforce in those positions getting to help remind everybody what the consequences of some of those decisions are. So we're working at it.
So that just means by the time Sydney's there, we'll be good.
Or your daughter, even better.
That's right.
For our final question, I would like to ask everyone on the panel for their final words of advice you would give to students like me as we go through school.
I'd like to start by saying something that's close to what Sally had a phrase that was always, reach for the stars. That's how she ended up her conversations with students and particularly girls. And I would like to say that if you truly have a passion or a desire, fight hard to maintain that and to not let things get in the way, because there definitely will be barriers. For girls, there's barriers for girls, there's barriers for boys, but stay true to your passions, because it will pay off.
I would agree with Karen. That's something I think all of us have experienced, and I would say in particular for girls going in that really challenge yourself. You are going to be surprised at how much you can accomplish. And lots of people have asked if this was my dream job, and I always say I would have never, ever dreamed of having this job. So really reach higher, as we like to say.
I completely agree with that. Working at NASA, and we do big, awesome things, and those things are often very, very hard. So you don't want to minimize, the challenges that you'll face in a challenging job, but that's part of what's so fun about it. Girls are every bit as smart as boys and can do all of those really challenging, hard jobs as well. So yeah, just to echo the last couple of speakers, is just embrace those challenges and be good at them, And then my second big piece of advice, and this was really important for me, is to find mentors all along the way. In high school, in college, if you go to grad school, find someone who has done what you want to do and get them to be your cheerleader and get them to help you. That's been one of the most key pieces of advice that I received when I was younger, and that I've been very fortunate to have been able to have really excellent mentors all along the way. And NASA obviously has a lot of really great programs like the NASA Girls Program and others that are set up in order to provide those mentorship opportunities. So that's very important.
And mine's a great follow-up to Amber. I would say don't be afraid to ask. Whatever you do, I think oftentimes we, more so than boys, are afraid to ask because we're afraid that it may not be the right question or will inconvenience somebody or, something like that. But don't be afraid to ask. You can ask your mom and dad. You can ask any mentors you've been around. You can ask your teachers, your neighbors, anybody who you think could help you. And even if that person can't help you, they'll probably know somebody who can. So I think it's, even at your age, you can build what we call your network. So I think it's very important to be sure you ask.
I mean, I agree. I mean, your questions, whatever they are, they're good questions, and you should ask them. You should figure out what kind of help you need, which probably would include a mentor, but I would sort of widen it to, what do I need and how can I ask for that? How can I arrange to get the things I need? Because I am a resource and I am part of the future. You should look in the mirror and realize that the things you need, the things you want to know, you need to get those things because you are part of the future. And then I'll just actually quote someone who's, I don't remember her name, but I was on a really neat NASA STEM panel with the chief engineer from Facebook, and she said, fail, and fail often. And I really loved that because, we tend to think that, achieving, going for these challenges that we're going to succeed. And if you succeed all the time, you might actually not be reaching high enough. It's okay to fail because we're doing hard things.
To the entire panel, thank you for having this conversation with me. And thank you for celebrating the life and legacy of a true pioneer, Dr. Sally Ride. Ironically, today is also the anniversary of Commander Coleman's flight as the first female space shuttle commander in 1999. How exciting is that? We have many reasons to celebrate that women have done, so girls like me can do whatever we want to do. Before we leave, I wanted to tell everyone about a resource page at women.nasa.gov/outreach. Visit this page for programs and other information for students. I am honored to represent NASA Girls today, and I hope someday I can be an engineer and make things even better. Thank you for watching.